with the logic. Now, here are some common problems that you can avoid when you're writing your papers, but also to look for when you're reviewing an article. Common mistakes in the title and abstract include the title being too long or short, or not accurate, or too informal. Or the title and abstract don't give important information such as the population or the study system, or they're too technical, or they don't define abbreviations. Maybe the abstract is too long or short, or omits important information so it doesn't actually summarize the whole paper. Or it's biased because the author has cherry-picked only the positive data that look good. A common problem is that the abstract doesn't actually correspond to the main text. Maybe the text says 50%, but the abstract says 55%. And the abstract should be independent or standalone, so there should be no references or any reference to the main paper, such as telling the author to look at Table 1 or Figure 1. Now, there's usually keywords after the abstract, so these might be missing, or there might be too few or too many, or not in the correct style, and some journals do want authors to use a specific word list. So if you see that the keywords have something wrong, you can also comment on this. In the introduction, the start could be too general or too long. Now, you have to make sure that the author is matching the readership of the target journal. So that means you also have to check the journal guidelines and its aims and scope statement, because a very specialist journal will have readers that already know the usual textbook information. They don't need information that's too general in the start. Check for logic, and check that the study has a theoretical background. It actually makes sense why the author is doing that study. Now, commonly, people forget to even put the problem or the aim statement, or it's too general, it's not focused enough. Or they miss out important references. So this means you can suggest them, but again, give unbiased suggestions of references. Sometimes the introduction names some topics and gives definitions, but they're not used again later on in the results and discussion. So make sure the introduction does introduce the rest of the text. Or sometimes information in the results and discussion comes up suddenly and wasn't explained in the introduction. So again, look for these logical mistakes. Now, in the methods and results, there might be no justification for using that specific method, or there's too little detail that someone won't be able to repeat that method. Remember validity and reliability, so you need to check these. Now, commonly the sample isn't big enough, or there's no controls, or the selection criteria aren't clear, or the variables aren't clear. And check for methods about the data processing and any correction steps, statistical tests, and ethical statements. Now, in the text of the results, the author shouldn't just list the data and repeat what's in the figures and tables. They should try to give the relationships and trends to the reader. Often the text doesn't match the data, so check the illustrations. Sometimes the author says increased, but the tables show a decrease. Check that unexpected or negative data are included, because that's also part of the results. And the author shouldn't be interpreting or giving opinions in the results section unless it's a combined results and discussion section. The data sometimes come up suddenly without being explained by methods, or sometimes the methods don't have any results. So do make sure that methods and results link to each other. And sometimes the figures and tables aren't even referred to, or they're numbered wrongly, or they're repeated. So look for these things too. Now, here are some display items with obvious mistakes. Now this one set of graphs, maybe there's too much information to show together, and they do look repeated, and there's no axes labeling, there's no color coding, legend labeling. The second graph and the third graph are stretched in different directions, and the scales are strange. So these would be things to pick up on. This one is very low resolution. You can't read the axes, and the y-axis, the vertical axis, has numbers missing. The tick marks stop halfway. And when you see error bars, you should always check that there's a footnote explaining whether they are 95% confidence intervals or standard errors of the mean or standard deviations. Now this one is a 3D graph which should be avoided in scientific publication, and again there's no title, there's no legends, and there are abbreviations which aren't explained. And in this case the author has mixed up the x and y axis. The independent axis, the independent variable should go on the x-axis, so that's the group, and then the dependent variable, which is the score, should be on the y-axis. Now this pie chart doesn't have a complete n number. We don't know the whole group number, so we don't know what the percentages refer to. And also if you add them up, it adds up to more than 100%. So pie charts and pie graphs should add up to 100. This table has too much detail and looks like it's just an Excel table, so do check with the journal whether they accept Excel tables, because sometimes the formula cells don't copy and the journal might want a different format, or the resolution might be bad if the author tries to convert it to an image. So display items should be clear and also standalone with enough labeling and legends for people to understand without the main text. Now in the discussion, common problems are that the findings aren't summarized and the unexpected and negative results aren't explained, and statistical significance is often confused with real-world significance, or because two groups differ by a big number like 20%, that doesn't mean it has a real-world meaning. You need to look at both. Also, don't confuse association with cause, and make sure that the author does discuss the results and compare them with other people's results, and don't just pick the ones that agree. They need to look at data that don't agree and try to explain that too. The author needs to discuss limitations, but not just repeat results from the results section and not introduce new ones suddenly. Sometimes there's no conclusion at the end, or the wording of the conclusion doesn't match the question wording or the actual aim, or isn't supported by the data. So many people overstretch their conclusions. They're too generalized, or they're too precise, or too confident. And it's always best to include implications in papers. So look for implications for use, for professional practice, for policy, and for future research. Now, it's a good idea, if you don't do this already, to practice analyzing articles in journal clubs. So get some colleagues together and regularly select a recent paper. Then you can keep up to date with the literature, and also analyze the strengths and weaknesses and practice your peer review skills. So that's brought us to the end. We've looked at the main aims and models of peer review, the best practices in peer review, how to read efficiently, the different parts of a paper, and common problems in research papers. Now, in Wednesday's seminar, I'll teach you about how to look for problems in academic arguments and how to actually write the peer review report. So it's a professional report for the journal editor, and it's useful for the journal and useful for the author.